Welcome to the first video in the Introduction to Simio module. In this video we'll cover several topics: the Simio user interface, the basic definition or description of Simio objects and the Simio object model, Simio data tables, and finally the Simio standard library. Note that a lot of this video, virtually all of the video, is going to involve definitions, and some of these definitions will be a little bit fuzzy until we get actually into the Simio modeling, but we need to get the definitions out there so that we can then reinforce them once we get to the actual building of Simio model. So for this video, just bear with me a little bit, and we'll get through the definitions and get to start on using Simio in the next video. So this is a picture of the Simio user interface, and the basic user interface has the following components. We have the standard file menu and ribbon structure that's standard for Microsoft Windows applications. The Simio specific components include a set of project tabs, the library on the left side, and so in this one we see the standard library, a indicator of the flow library and the project library. So you can have different libraries in the library section. We have the project over here on the left side where it says navigation and browse. We have the current model, which is highlighted in the project. We have the properties, and the properties define the properties of the currently selected object in the model. And then we have finally the facility view, which is where we do the majority of the interactive modeling inside the facility view. So one quick note of something that's typically confusing that I'll come back to several times. The project tabs differ based on which object is selected in the project. However, there's quite a bit of overlap. So a lot of times you'll be working on, say, the definition tab, and you might have the wrong object selected, and that will be confusing. And so that's just something to keep in mind as we move forward, that is one of the things that tends to confuse new Simio users. So first in our set of definitions is some key Simio object concepts. And so as we see on the slide, Simio has three basic object components. They have the objects, the models, and the project. And a Simio object defines the data, the logic, behavior, view, events, and interaction with other objects within the model. A model is simply an object that is executable, and again we'll see this when we get into modeling with Simio. And a project is a collection of models, objects, and a project can be loaded as a library. So a project and a library can be used, the terms can be used synonymously. Properties, states, and events, critical concepts, and so properties and states are both defined characteristics of objects. A property is a static characteristic, so in other words it can't change over the run of the model, whereas a state are changeable values associated with an object. Events support communication between objects, and an event is fired when key things happen. So when something occurs within the simulation model, the event can be fired, and objects can be listening for the firing of that event and then react accordingly. Resources constrain the system, so an object can be defined as a resource. So a resource essentially models things like machines. They can model people where they provide some type of service but their capacity is constrained. An entity is a dynamic object that moves through the system. And finally, a transporter is an entity that can carry or work on other entities. So we think about a vehicle that might carry an object. So I might have an object that represents a part in a manufacturing system and a vehicle that represents a transporter or a forklift, for example, and that transporter can carry the part entity through the system. I could also think of a transporter as a person. So for example, in a healthcare system, I might have a nurse that acts as a transporter to escort a patient through the corresponding system that's represented by the model. The next important concept for Simio is something called a process or Simio processes. And a process is, as shown here, is a set of actions that take place over simulated time, and it may change the state of the system. And so we see an example of a process down here at the bottom where we have a typical seize, delay, release sequence where we're requesting a unit of capacity of a resource. We're going to delay for some period of time, and then we're going to release that resource. So in this context of actions that take place over time, think of this as like a patient in a healthcare clinic that's trying to have access to the doctor, and so there might be some time delay while the doctor arrives or becomes available. Once that happens, then there's another delay for the doctor to treat or assess the patient or whatever task you're modeling, and so there's another time delay there, and then finally they release you release the doctor to go meet other seize requests. And so in this particular example, there would generally be some type of time simulated time delay. An add-on process is simply a process that is executed in the normal flow of operation of a Simio object. So we would define a process, and then we would sort of inject this process at some logical position within the object functionality to modify the behavior of that object. And so we'll see this in some detail over the next several videos. Steps performed, so the processes are composed of a series of steps, and they can perform a variety of things. The seize, delay, release, which we just saw. We can also fire an event or wait for an event. We can have decision steps where we're making some kind of probabilistic or conditional decision. We can move entities around. We can search through populations of entities, and so it's processes can be considered sort of the workhorse of Simio, and all of the objects are built on either other objects or processes within Simio. Another important concept in Simio is the use of Simio data tables. And a data table is simply a standard tabular representation of data where we have rows and columns, where the rows represent generally observations of data, and the columns represent particular characteristics. And many of the models that we are interested in dealing with deal with large amounts of data, either model description data, operational description data, or performance data that is actually generated by the model. Simio represents data in a very simple tabular form, but can also represent relational structure within data. And it's this ability to easily handle the relational data structure that gives Simio quite a bit of its power. Finally, for this video, we'll talk a little bit about the Simio standard library. So as we'll see when we get into the model building exercise in the next video, Simio modeling to a large extent involves dragging objects from libraries into the facility view, connecting those objects in a logical way, and setting the corresponding object properties. So the standard library can be divided into a sets of objects based on their behavior. The first set is the creation and destruction of entities. So the source objects create entities, sink objects destroy entities. The second set of objects are basically servers, or represent machines, or where processes take place. So we have a basic server, which models a capacitated process. We have a combiner, which allows you to batch entities with a parent. So for example, I want to create a palette of 48 individual items. The combiner would facilitate that. A separator splits batches, so I could take that same palette that I created and split into the 48 entities plus the palette. And the separator is also used to make copies of entities, as we'll see. We have the set of resources. So we have just a standard resource, a basic resource, which provides a capacity that entities can seize and release. And so it provides a mechanism to implement a capacitated server or capacitated resource. We have vehicles, which provide that same capability, plus move throughout the model and can have on-demand pickups and drop-offs and so on. And finally, we have the worker object, and the worker object is similar to a vehicle object, except it is more in line with a person that is moving around and performing tasks. The graphical notation that we'll see has sets of nodes, and we have two basic types of nodes in the standard library. There's a basic node and there's a transfer node. And finally, we have links that model entity travel between nodes, and there are 4 basic link types that are defined in the standard library. You have a connector which models a zero travel time, so I go from one location to another in 0 time. I have paths where entities independently move, and so the duration of the transfer depends on the length of the path and the speed of the entity. I have a time path in which all entities traverse the path in the same time. And then finally I have a conveyor which allows me to model accumulating and non-accumulated conveyor devices in manufacturing systems. So that completes video 1. And in the next video we will actually get into some sample Simio modeling.